Hi everyone, my name is Sofia Casas. I'm an applications engineer at Telewave, and today we want to talk about how to tune a pass cavity. So let's start. Let's start with an overview about a pass cavity. Here a pass cavity has two holes or two loops, and here we have an internal view about the cavity. We can see here the coupling loops, the tuning knob. We can see the inner conductor. That one is a fixed part. Here we have the inner conductor, but this one we tune it with the tuning knob, and this up and down to select the frequency that we want to pass. And we have the shell that also is an outer conductor.
All right, let's start. So here we have our cavity or pass cavity, and we're going to use this VNA. I have got here all the tools that we need to do the tuning. So our cavity is already connected, and on the screen you can see the tuning that we currently have. Right now the frequency is 456.025 megahertz, and we need to change it to 461.025 megahertz, which is the frequency that is written on the label physically on the cavity. So to change the frequency, we're going to move the tuning knob using our nut driver, and we are also going to use this open wrench to hold it. When we turn it to the left, we go to a lower frequency, and when we turn it to the right, we got a higher frequency. As you can see on the screen, the trace moves while I'm moving the knob, so we will keep moving it until we reach 461.025 megahertz. All right, there we go. Now, if we look at the markers here, it's showing a return loss of 18.52 dB and an insertion loss of 0.89 dB. So that's good. We are right with specifications. So just to let you know, for a transmitter, we should have at least 18 dB of return loss. And for the receive side, we usually use 14 dB. So if you are tuning a pass cavity that is going to be used for a transmitter, make sure that you have got at least 18 dB. If you get 20 dB, 22 dB, even better. The higher it's the better, all right? And for the receive side, make sure that you have 14 dB minimum just to protect it. If you get more, like 15, 18, or 20 dB, that it's also great. So now we can say that we are done with the tuning part when we tuned our frequency that we want to pass. So we just need to secure this one so it doesn't move when we install the cavity later or when we install the cavity on the field on the side. So if you look at the software, you will see that the frequency changed a little when I secured the nut. So you need to tuning it with the nut driver and secure it with the open wrench at the same time to keep it steady and avoid changing tuning. So just lower a little bit and then fix it. Okay, again. Then fix it like this. Okay. All right, now we can reduce the span to make easier to see. So let's go down to 5 megahertz. So there we go. Now it looks much clearer. So at this point, you make a better tuning, make a more precise tuning of the frequency you want to let throughout. Okay, so now if you look at the pass cavity, we need to balance the return loss. Okay, with this VNA, we can actually see both sides, input and output, at the same time. We don't need to switch the cables. For a bandpass cavity, we need to balance the return loss on both sides. So here we have 16 dB and here we have 19 dB. To tune that or to get less or more insertion loss, so remember, just fun fact, the standard insertion loss that we have in a bandpass cavity is 1 dB. 1 dB of insertion loss, right? So you can get more selectivity, but you will also have a higher insertion loss, or you can have less selectivity or lower Q and less insertion loss. So we need to tune that by moving the loops, both of them, and I'm just going to move one to show you how it works. So let's grab our screwdriver and look. Just a teeny movement changed everything. Uh, see, give me a second. You can actually see the trace move in the software here. If I move it, you will see more insertion loss. And then on the other side, I'm gonna have less insertion loss. So the goal here is to balance both sides. We need the same insertion loss at the same return loss on both screens at the same frequency. So let it set it to 1 dB of insertion loss. We're gonna tune it at 1 dB insertion loss. I changed the scale. Here it's 10 dB per division, and on the other screen it's 25 dB per division. So that is just to make it easier to compare, but it's the same value. Okay, now we have okay, let me see. Remember, we need to balance return loss, right? Okay, now we have 23 dB of return loss here. 23 here and 9 and 70 on the other side. So let's try to move the other loop. Let's adjust. Let's tuning again the other loop. So we here can see how affect. Okay. Okay, now it's 17, 21. We almost there. Okay, I think that's finally 19, all right? That's close enough. So now we have got 19 and 19 dB of return loss, both screens. We need to move need to move it, the tuning knob. So here we have 1 dB of insertion loss, and we have balanced it. So that's it. We have finished retuning the band pass cavity. So just remember, for transmitters, always keep at least 18 dB of return loss, and for receivers, you need at least 14 dB of return loss.
Thank you for watching this video. I'm Sofia Casas, and don't forget to like and subscribe. If you want to learn more about our products or if you want to contact us, just visit our website. Have a nice day.